Hello and welcome in to the first video, the content video for lesson 8 for Precalculus 2. In this video, we're going to look at our law of cosines. We're going to look at navigation. So if we're given navigation problems, how do we handle those? And also we're going to look at our second and our last formula for the area of a triangle, which is known as Heron's formula. Let me share my document camera with you guys. So in lesson 7, we had law of sines, which we could use when we did not have a right triangle. With law of cosines, that's also going to apply. So we don't have a right triangle. We don't have a right angle anywhere. But the difference is, so law of cosines. So with law of sines, it was always what? An angle and the side across from it. An angle and a side across from it. Law of cosines, we use when we do not have a right triangle, but we have two sides and the included angle. And so that's what? That's the angle between them. Or we have all three sides. So if we're given a triangle and we have side A is whatever, 3, and side A is 5, and side C is 6, I can figure out all the angles in that triangle using law of cosines. So law of cosines is as follows. So A squared, which is side A squared, is equal to B squared plus C squared minus 2BC times the cosine of angle A. So if I have some triangle here, let's go A, B, C. So this is side A, this is side B, this is side C. So if I want to find what's side A, and I have side B, sorry, if I want side A, which is over here, and I have side B and C, and I have angle A, I can figure that out. I can figure out side A with this formula. Now, when I drew this triangle, I put A, B, and C here. But for the most part, they're arbitrary, right? What I call angle A, somebody might call angle B, or might call it angle X, XYZ, something like that. So this is the formula. We can write it out for all the individual ones. B squared is A squared plus C squared minus 2AC cosine of angle B, or C squared is A squared plus B squared minus 2AB cosine of C. So the important thing here is what? The side on the left side of the equal sign has to match up with the angle over on the right. So I couldn't say B squared is A squared, C squared, cosine of A. That doesn't make any sense, right? Because it's not even the included angle. I'm figuring out the side A because I have this included angle A. So I can plug it into the formula, and then I have this side and this side. So I need these three pieces of information in order to find the side across from it. And so again, when we're setting this up, just be careful that the side you're finding is the one across from the angle that you have. Or if you're given all three sides, you're finding that angle. So let's say I was given side A, side B, side C. I can find angle A using this first formula equation. I can find angle B using the second equation and so forth. So the next topic here is navigation. And this gives people, hey, what's up, bud? What? This gives people a lot of trouble. And so, first of all, let's go to our compass here. So we have what? North is to the top, south is to the bottom, east is to the right, west is to the left. And so, again, if you have trouble remembering this, and I know some people do like never eat soggy waffles, NESW, you can do that if that works for you. But otherwise, if you're trying to fit, if it's like, wait, which one goes where? Well, just pretend you're in Las Vegas because that's where UNLV is. So what's to the north of us? Well, that's Canada. Okay, so that's Canada's to the north. What's to the south of us? That's Mexico is down below us. What's to the east? Well, that's New York is way over to the east. And what's to the west? Well, LA is over to the west. So you wouldn't say New York is west of Las Vegas. It's not, right? It's east. It's on the east coast. It's over to the right. All right. So now that we have northeast, southwest figured out, hopefully, we have the following. In navigation, a direction is often given as a bearing. And so you'll a lot of times hear me say it's a bearing navigation problem because they're related to each other. So that is what bearing means is an acute angle, so less than 90 degrees, measured from due north or due south. So due north is where? It's here. Due south is what? It's down here. And so if it's measured from due north or due south, it means the following. When you are drawing these pictures, so for example, let's say I have north 30 degrees east. That is a bearing that is indicating navigation to us. When we do these, when I draw this, the angle must, absolutely must touch the y-axis because that's my due north and that's my due south. If I draw a picture and this angle that's given to me is touching the x-axis, my problem is completely wrong. I've drawn it incorrectly. What north 30 degrees east means is that I go from due north, which is up, and I need 30 degrees going towards the east, which is the right. So this is the direction that I'm headed. The 30 has to touch the y-axis. 30 degrees goes in here, heading towards the north, but off to the right because it's east, 30 degrees east. So that is what our navigation, that is what our bearing problems are going to look like when we draw them. The angle must touch the y-axis. I would write that on your cheat sheet. I'd get out your highlighter and highlight the whole thing. And I'd pull out my red pen and I'd write caution because I cannot tell you how many times I see people on a test do, oh, north 30 degrees east. Okay, here's my picture. Well, you might as well stop and move on to the next problem because you have zero chance of getting this right if you draw this as north 30 degrees east. That is not what north 30 degrees east looks like. All right, off my soapbox. I think you get it. I think you understand how important it is. So the last thing that we're going to be talking about here is what's called Heron's formula. And this is for area of a triangle given all three sides. So our other area of a triangle formula that we had was when we had two sides and an included angle. And that was what? Area is 1/2 AB sine of theta. Now, if we have all three sides and we want the area, it's given by the following formula. Area is equal to the square root of S, and we'll talk about that in a second, times S minus A, side A, times S minus B, side B, times S minus C, side C, where S is equal to 1/2 times A plus B plus C. So add up all the sides, multiply it by 1/2. That's the number you're going to use here for S. And then you're subtracting all the sides from that number. And this is what's called the semi-perimeter. So if somebody ever says, hey, what's the length of the semi-perimeter? Semi-perimeter. Sorry. Talking and writing at the same time, not good. Yeah, so if someone says, hey, what's the semi-perimeter of that triangle? You just add up the three sides and divide by 2. And that's it. So when you're given the problem, you want to find the area and you're given three sides, you just use that formula. Make sure you calculate S properly, and then it's just a bunch of calculator work. So that is it. That is the content video for lesson 8. Again, another shorter one. You kind of paid the price in lesson 6 with those extra long videos. So a couple short ones here. Come on back. We'll work a few law of cosines, area triangle, navigation problems. And we'll see you in video 2.